So hi everyone, myself Pankaj and welcome to the next video of solving most important DSA interview questions. So in this video, we are going to solve a problem which is based on a sorting algorithm. So the name of the problem is sort an array. So in this problem, you will be given with an array of integers, nums, and you have to return a sorted array. Sorted array means basically you have to arrange its element in ascending order, means from smaller to bigger, and you have to return that array. They have given a condition that you must solve the problem without using any built-in functions. So if you are using C++, you must be knowing a built-in function name as sort, right? And in that sort function, you basically provide the array which you have to sort. But we don't have to use that built-in function. We have to we have to write an algorithm to solve this question, right? And the time complexity should be big O of n log of n, and with the smallest space complexity possible. So you have to solve this question. So here you can see that the first input is 5, 2, 3, 1, and you have to return the sorted array, right? So you must have learned too many of sorting algorithms like quick sort, bubble sort, merge sort. So we have to use one of them, and we are going to use what we called merge sort, right? Merge sort. Why? Because the worst time complexity of merge sort is basically big O of n log of n, which is smaller in all of its algorithm family, right? So we will be using this merge sort algorithm, and so let's see how you can utilize this merge sort algorithm to solve this question. So here I have taken an example. In this figure, you can see that you are given with this array, right? So you are given with this array, right? So here, this is the array, and you have to sort it out, right? So what we do in merge sort is basically we first divide our array into two equal parts, right? First of all, what we do, we will find a mid. So here you can see that there are how many elements? 1, 2, 3, 4, 5, 6, 7, 8. So 8 is the number of elements. So what we will do, we will first find the mid of this element. So what will be the mid of the element? So it's basically mid will be basically what? 4, right? Or if you use zero based indexing, so the index will start from 0, then will go up to 7 here. So in this case, the mid will be basically 3. Basically 7 plus 0 by 2 is basically 3. So mid will be here, right? So what we will do, we will basically divide this array into two parts around this mid, right? So this is the two array that we have got, right? Now recursively, we will again divide this array by finding the mid. So its mid will be right here, and we divide it into these two subarrays, right? So these two parts, right? Similarly with this, and again we will recursively divide this array until we reach to a single element, right? So here you can see that we have found all the single elements, right? Now you know that single elements are already sorted. Let's say you are provided with this array with single element, that is 5. So it is already sorted. You don't have to sort it out, right? So this is sorted. This 2 is sorted already. This 4 is already sorted. Similarly, these all elements are already sorted, which are of single length. Now, what we will do, here comes the merge sort algorithm. What we will do, we will basically merge these two elements in a sorted manner. So you can see that 5 and 5 was earlier of 2. So what we here did that, we saw that 2 is basically smaller than 5. So what we will do, we will basically keep our 2 first, then 5, right? Similarly, with these two elements, already this 4 is smaller, so we will keep 4 first, then 7, right? Similarly for these two, then these two, right? So we got this length 2 array in sorted manner, right? Now what we will do, we will again compare these two array, right? And again check. So basically we will start with these, let's say with an index here and one index here, right? And we will compare whether 2 is smaller than 4, which is smaller from 2 and 4. So 2 is smaller, so we will keep 2 first, right? Now we will move our index forward. So our next index will come here, and in this case it will come here. Again we will compare 5 and 7, which is smaller. So 5, okay. So what we had done previously, that our first index was here, and in this case the index was here. We compared that 2 and 4. So 2 is smaller, so we keep 2 here, right? Now this index will be gone forward from here to here, right? Now again we will compare 5 and 4. So which is smaller? So 4 is smaller, so we will keep 4 here, right? So this index will move forward, and again we will compare 5 and 7. So 5 is smaller, so we will keep 5 here, and we will move this index forward. So you see that this index has gone out of the bond of this array, so we will not compare. Now only 7 is left in these two arrays, right? So we will automatically add 7 here. We don't need to compare 7 with any other elements, right? So after doing this operation, you saw that we got an sorted array. Similar operation we will perform on it, and we got a sorted array. Again, the same operation we will start for these two arrays. Let's say one index will be here and other index will be, let's say one index will be here and other index will be here. We will again compare this. So one is smaller, one will come first, then index will go forward. Again we will compare 1 and 2. So 2 and 2, so 2 are both are same, so we will keep these two here, right? So this will be done using recursion, right? So you don't have to think how it's working. And if you want to find how it's working, so basically you will have to dry run this example, right? So use your pen and paper and dry run this operation, right? So we have to do two things, right? First, what we will do, we will first divide the array into smaller parts, basically two equal halves, right? Until we get these single elements, right? So it will be done using recursion, right? Now again we will use another function for merging these elements in a sorted manner. So these two combined functions are basically called as merge sort, right? So I hope you have understood this logic. So let's come to the code. How is its code look like? So here you can see that this was our original function, right? That was given in our function question, right? So what we did is first we find the length of this nums array that you are provided with, and basically we created a merge sort function, and this is basically your starting index and it is your ending index, which is n-1, right? Now what we did is inside our merge sort function, so I said that this is the starting index and ending index, right? So first of all we will use a base case here. So this is your base case, right? So what does it mean? If your starting index is getting greater than ending index, so in that case you have checked all, you have basically got a single element, right? So in that case you have to basically return, you don't have to do anything, right? Now what you will do, you will first find mid index, right? So you can also find mid index as e plus, so basically e plus s by 2, but I am using this case here basically handling the overflow. Let's say your e is 10 to the power 9 and s is also 10 to the power 9. So in that case if you will add, so basically let's say your end is 10 to the power 9 and your starting is basically so basically end is basically greater than 10 to the power 9 and our starting is basically 0. So if you will add this, so it will not fit under integer data structure, right? Integer variable. So so for handling that case, first of all what I have done is I have subtracted that value s from e and divided it with 2. Then I added this to s, right? So if you will solve this equation, you will automatically get that this value e plus s by 2. But here we are handling that overflow condition, right? Now here we have find our mid index. Now what we did is first of all we will call our, so let's say what we did so here what we did, we found that mid index and what we have to basically divide this array into two equal halves. So for dividing these two equal halves, let's say, so what I have, so basically let's say you got this after recursion you got these two arrays. So these two arrays are basically what we have to create two different arrays, right, for storing this sorted part. So the same thing what I am doing here is that first of all I called merge sort for half part, left part, then merge sort for right part, right? So in these two function calls we are basically performing this operation, right? Basically until here we are dividing this array until we got single elements, right? So these two function calls are doing the same, and after that we got single elements. What we did, we are calling another function that is merge, right? And in this function what we are doing, we are basically creating a new array. So this is a new array, right? So this is a new array, and in this array we are, so this is new array which is sorted, right? You can see here 2 4 5 7 1 2 3 6, these two arrays are sorted, right? And we have to merge them in a sorted manner to form this array, right? So we will have to create this array first, right? In order to create this array we will have to create these two arrays. So here what I have done is first of all I found the index, mid index, right? Then we find the length of the first sorted array. So here you can see that first of all what I did, I first found the length of this array and also the length of this array and created another array, right? Another, so this is not already created, so I am finding this length using this mid and starting and ending index, right? So first of all, I found the length. So here you don't know the length of this array, but how you will find it? So by let's say its mid was here, start was here, and end was here. I'm sorry, for finding the length of this array, this sorted array. So in that case, what will happen? Your mid will be here, right? So to find the length of this and start here, end here. To find out length of this, what you will do? You will basically for finding the left part length, what you will do? You will basically do mid minus start plus one. So then you will find this length. And for finding the length of this second part, you will do basically end minus mid, right? So the same thing I am doing here, right? Now I created that length two vector. Why I created two vector or array? So in order to store this what sorted array, sorted values, right? So I created these two vectors. Now I'm copying this value in these two vectors, right? So I copied these values here and here also, right? In the left part and the right part. Now now here we got these two sorted arrays. Now we have to merge it out. So what the operation I had said you that we will use two index here and one index for this main array index, right? So what we will do? We will compare these two elements. Whichever is smaller, we will insert it out here, right? Again, we will compare these elements from these two arrays, and whichever is smaller, we will keep that element at the second place of this array. You can see here, right? This we are updating the same original array that we have got in our question or problem statement, right? So we copied these arrays, right? Now we will what we will do? We will basically comparing that whether the left array first element or right array element is smaller. Whichever is smaller, we are updating that element or assigning that element to the original array, that is our nums array, right? Now if whenever the left or right part is bigger, we will have to copy that out until our full array is copied, right? So we are handling that case, right? So these are two cases, right? So this is the basic logic of the merge sort. So I hope you must have understood this problem. At the end, what I am doing is basically returning the nums. Why? Because here I have updated the nums array, right? So this is the working code, and I think you have understood this. So let's meet in the next video. Until then, have a nice day.